record. All right, we've only got 8 people here to start, but I'm going to go ahead and start anyway, simply because we have a lot to cover today. And it seemed like a lot of people said they were okay if it ran over by a few minutes. So I kind of just made this PowerPoint of what I wanted, and I didn't really worry about time. So it might take us an hour and 10 minutes to get through it. I don't know. We'll see. Of course, you are on your own. You're in your own world on that end of the computer. So at any point in time, if you want to bail out, just kind of keep track of what time you left. So if you want to watch the video later, if you left at 1:40, you want to pick up at the 40-minute mark, you know, that kind of thing. So this week we are covering modules 3 and 4, which is sections 6, 7, 8, and 9. So basically we are covering the second half of Unit 1 this week. And so quite a few of you have already started. Some of you have already finished the homework in this section. It makes me very, very happy to see that. So some of you are working well. Some of you are not working at all, or very little. But I think, of course, the people that are here are all working. So thank you for putting the time in. You've got 4 sections of web work, 2 quizzes, 2 Excel documents, 2 discussion boards, and Project 1 is officially assigned in Module 4. You will notice there's an asterisk after Project 1 and the Excel documents. I posted an announcement earlier today, about 45 minutes ago, and there are 3 videos. All of them are under 10 minutes. I think 2 of them are under 3 minutes. And one is about inserting pie charts, one is about descriptive statistics in Excel, and one is about Project 1. So if you are working on any of those 3 documents and you're like, wow, I have questions, you can go and watch those short videos and they will kind of help walk you through how things work. And of course, you can always email me. I don't want any of you to ever feel like you're bothering me when you email me. Please, that is what I'm here for. That is my job. I tend to do a lot of work in the evenings. So, you know, I'm going to pick on Lori. She just arrived. I was working on my computer from 8 to 11 last night. I got other things that I'm doing. And we exchanged emails about 4 times. And that's fantastic. That's what I want. If you have a question, email me. I will get back to you as soon as I can. Or in Jessica's case, 2 days later when I forget I had an email. So, you know, I want to help you because I understand how frustrating it is when you have a question and you feel stuck and you can't move forward. So let me help you move forward when you get there. Okay, so reach out. You know, you can work on so many different assignments at the same time. So if you get stuck in homework 6, you know, forget it. Move on to homework 7. Email me. That way you can continue to work, but then I can get back to you on where you're at. So, yeah. One other thing I want to mention on this page, quiz 3 and 4, I know have issues. There's a coding issue, and it's my fault because I built this class. I don't exactly know what the issue is, but I know there is one. Probably starting tonight into tomorrow, I will be regrading all of your quizzes, so I will be going in and making sure that anything that was marked incorrect, if you got it right, it will be fixed. So you will get points awarded back to you. So don't worry, I will be going in. You will not lose points for anything just because I don't know how to code in Ivy Learn. So, but feel free to keep emailing me when you think those things are coming up. That's important. Communication is key. So let me know what you find. Okay. So if you have any other questions about that, whoa. That must have been me. Any other questions, you know, just let me know. You can shoot them in the chat box. I'll try to keep up on that as we go through. But we're going to go through these 4 sections, 6, 7, 8, and 9. And then after I get through all of that, I do want to talk about Project 1 just a little bit. I do want to talk about Exam 1 just a little bit. And then if you have any additional questions, we'll go from there. So I'm not really going to pay attention to time. I'm just going to kind of go with the flow and see how this class goes. If you need to leave, again, please do so. And you can just watch the end of the video at a later time. All right, so let's see what we got here. Section 6 talks about the GDP and a little bit of CPI. So we get into some alphabet soup in Section 6. And really, neither one of these is difficult. It's an application section, but if you don't know what it is, that makes it difficult, right? So I want to talk about the GDP just in general. Can anybody tell me what the GDP stands for? If you can't, that's fine. The GDP is the gross domestic product. This is basically the value of all, oops, that should be a D, gross domestic product. The value of all goods and services produced by a country is the gross domestic product. And we're going to do a problem here on the next page that talks about the gross domestic product per capita. Because when there's a page in your packet, and I know you're all working through your packet because you're excellent students, that talks and compares the GDP per capita among different countries, right? It's not fair to compare Madagascar and China in terms of gross domestic product because China's got just a ton more people. And so you can't necessarily talk about total gross domestic product, but you can talk about per capita. So that's just kind of in general. Okay, the next thing we're going to talk about, we're going to do math here in just a minute, don't worry, but the CPI, and you're going to be sick of CPI by the end of this world. CPI is the Consumer Price Index. So the Consumer Price Index is what we use to talk about inflation, right? How much things have increased in terms of price or cost over time. So the Consumer Price Index, basically how it's figured, there's a basket of goods and services. So it might have like eggs, maybe a quart of oil, tampons, pack of pens, whatever, all kinds of crap. And every month, these items are calculated. How much would it cost to buy these items? And then they figure out the percent increase, decrease, and that's how they figure out inflation. Right. So if you look on page 44 in your packet, sometimes we are going to need our packet for certain things, and today is one of them. On page 44, you have the annual CPI values. We're going to need those to do some math problems here. So if you have page 44 nearby, fantastic. It'll make your life just a little bit easier here. All right, so that's your general world. Now let's go to some math. And again, just reminding you that we're not going to do math problems that are in your packet. We're going to do Becky specials because you can watch videos for the packet. You don't need to see it in a video and here in class. So here in number one, we've got in 2005, the federal debt in millions was 1,436,200 million. And the population of this country was 120 million. All of these problems are made up by me. All right, so first order of business, we want to compute the federal debt per capita. And before we get started, I do want you to answer a question. And when I say you, I mean somebody. When we say per capita, we talked about this last week. What does per capita mean? Per person, exactly. So when we're talking about the federal debt per capita, we're talking about federal debt per implies division, and then we want the people on the bottom. So when we're talking about words, the first thing we want to do is put the federal debt in the numerator. So look at our federal debt. We've got our 1,436,200. Is everybody okay with what I just wrote as my federal debt? Happy, unhappy? Got a thought process? Am I missing anything? Obviously, I'm missing something because I pointed this out. It says in millions, right? So we've got this big number, and then it says in millions. So we would add million on the end of that. Okay? Then we're dividing by the people, and the people are 120 million. Now, this particular problem works out nicely because the millions then will cancel out. They cancel out because they are the exact same unit. If you have different units, it doesn't work so well. Okay, so those cancel out nicely. So when I'm figuring out my federal debt per capita, I simply have to divide my 1,436,200 divided by 120. When I do that division, what do I get for an answer? Excellent. So 11,968. And Samantha, I'm only going to correct you just a little bit. We're talking about money. So anytime we're talking about money, we want to go to 2 decimal places, right? So that's kind of a general rule. Unless otherwise stated, anytime you're talking about money, 2 decimal places, right? That's kind of your basic dealio. Okay, so hopefully that's kind of a review from last week. But now I'm going to take this same first part of number 1, and I'm going to move on to part B. So let me do that. Okay. I wish there was a way to erase some, but not all. Does anybody know how to do that? Oops. I don't know, we're just going to erase it all. Okay, so now we're still at the same part of part 1, federal debt and how many people, but now part B. It says if the federal debt increased by $1.4 trillion between 2005 and 2015, what was the new debt in 2015? All right, so let's think about this. Our old debt in 2005 was $1,436,200 million. And it increased. Increase tells us to add by 1.4 trillion. And I'm doing this problem here today in class because there's a problem similar to this in your homework, and it tends to cause people issues. And it causes people issues because we're comparing millions and trillions, and you can't play like that, right? You've got to be in the same units if you want them to play nicely. So does anybody have any idea, and it might help if you unmute yourself and talk just to share it on time, any idea how we can change these numbers to get them to be compatible or to play with them nicely? Because you've got a couple different options. No, nobody wants to. Jessica says turn them into decimals. Well, turning them into something would be good. We definitely want to change them. That is for sure. Let me
Notation?
Wait, say that again.
Scientific notation?
Scientific notation would be beautiful. Who said that?
Christy.
Christy, thank you. Yeah, that's one very good answer. I mean, we've dealt with that before. So let's keep that thought process, scientific notation. What does million tell you if you're talking scientific notation? How many? This is something you should have done on your own in the packet.
6.
6. So we would end up, okay, so just keeping this as it is. Million tells us that gives us times 10 to the 6th. What does trillion give us? 12. Thanks, Abby. Okay. So at this point, all I did, right, this is not beautiful scientific notation because the top number obviously is not between 1 and 10, but I took the words and turned them into scientific notation, or at least power of 10 notation. Now, this is kind of where, I don't want to say the math goes out the window, but you think a little bit outside the box. This first number, if we go pure scientific notation, 1,436,200 is a large number. My exponent's going to get bigger. Well, if I want to go from 6 to 12, if we want to add these together, we have to have the same power of 10. I need, how many places go from 6 to 12? What do you add to 6 to get 12 is my question, I guess. 6 plus what gives me 6? Thank you. Thank you, Alyssa. Very good. Look at all those 6s coming in. So I want to take in this top one, if I move my decimal 6 places, 1, 2, 3, 4, 5, 6, now I have 1.4362 times 10 to the 12th. So this is kind of my new problem here, roped around in green. So if I would add these together now, 1.4 plus 1.4362 is 2.8362, and that's times 10 to the 12th. So the new debt would be 2.8362, 10 to the 12th is trillion dollars. And there's your answer. I guess I should put a dollar sign in the front of this. Key to this problem is recognizing and understanding that you can take problems that have the word million at the end and you can change them to be other pieces, right? We went from 6 to 12. We went from millions to trillions simply by moving the decimal 6 places. And that's all place value that we talked about in whatever section that was earlier. So it is going to be important that you understand million is times 10 to the 6th, trillion is 10 to the 12th, billion is 10 to the 9th. All of those in your head would be a very, very positive thing. Okay, so there is a question in your homework that is kind of similar to this. It's going to be a little bit different, but that concept, this concept of changing numbers is going to help you. And of course, I think there might be a hint video, but if you get stuck, shoot me an email and I will do my best to help you. All right. Thank you for the participation on that one. Let's now go to, there we go, Consumer Price Index. Okay, so Consumer Price Index, I talked about it a little bit, being the price of goods and services that you and I purchase, right, and the inflation as it goes up. So, question number 2. And this is where you're going to need page 44 in your packet. I purchased a bike for $900 in 2014. What would have been a comparable cost for 1980? Now, when you use the CPI or Consumer Price Index, you are assuming that all of these, whatever it is, goods, services, whatever, we are assuming that they grow with inflation. We know some things grow faster than inflation, some grow slower than inflation, right? The price of bacon in the last 5 years has grown faster than inflation. So different things grow at different rates. We assume for these problems that everything grows with inflation. Okay, we're going to do one of these together, and then problem number 3, I'm going to cut you loose and I'm going to have you guys try one on your own. So you'll notice that we are comparing 2 years. We are comparing 2014 and we are comparing 1980. All right, now I set up, I'm a creature of habit. So when I do the CPI problems, I always set them up the exact same way. And I know that I'm using the CPI problems when I read a problem and they're talking about a comparison over time, 1980 to 2014, and they're talking about money. So money and time are the 2 key pieces for these CPI problems. So you can see I have time, and I'm gonna set up a proportion where my left ratio is 2014 and my right ratio is 1980. I'm going to put money on the top, and I'm going to put my CPI value on the bottom. The CPI value is what we're taking from page 44 in our packet. So you can see in our problem here that my bike was $900 in 2014. Well, that's money, 2014, so 900 goes here. I'm trying to find a comparable cost for 1980, so this is my unknown value of X. For the bottom, our denominators, the CPI values come from the table. So if you look at page 44, you will see that the annual CPI value for 2014 was 236.736. That's a 3. And for 1980, it's 82.4. Once I have, that's the wrong button, once I have that written, all right, now it's just a proportion, which we solved 500 of those in, over the last week. So we're going to solve, cross multiply and solve that. Can anybody give me a price for this bike? Should I have purchased it in 1980 before I was alive? Oh, there's Nathan, right on it, lickety split. 313.26 is correct. And again, good work. We're talking about money. If you're talking about money, then everything should be rounded to 2 decimal places, right, to the nearest penny. All right. So here we go. That was one we did all together. How to set it up. Anybody have any questions on how to set it up or where the numbers came from? Shoot them in the chat box if you do. Otherwise, I want you to try this one. So a house was purchased for $49,000 in 1978. What would have been a comparable cost in 2007? Round to the nearest penny. I'm just going to give you a minute or so, and then we will talk about it together. All right, one thing I don't like about this compared to our last format that we used is I used to have a button that people could click if they, once they had it or if they agreed, and I don't see that button here, so it kind of bothers me. But anyway, all right, so hopefully setting them up, and again, just like we talked about last week, when you're dealing with proportions, every proportion can be written 4 different ways. So this is just one way to set up these proportions. I just like it because it gives you a nice consistent format. So you've got the years across the top, you got money in the top, CPI on the bottom. We've got a $49,000 house in 1978, an unknown value for 2007. 65.2 is your CPI value for 1978 based off of page 44, and 2007 would be 207,342. So as Nathan so nicely put in, as well, a few people. No, you're good. Don't apologize. I said nicely. 155, 824. I have 51 cents. I don't know. Did I round wrong? Or did you guys round down? If you look at the third spot, does it round up or down? Should be 51. Thank you for confirming that I wasn't crazy this morning when I was doing that. All right, so you can see if you bought a house in 1978 for $49,000, it increased with inflation. In 2007, it would be worth roughly $155,824.51. Might depend on how you round, if you take different spots and round differently. So just make sure you show your work and you'll be good. All right, so that's CPI. Does anybody have any questions on CPI, where these numbers are coming from, how that works, whatever? In your homework, you will need page 44 from your packet to do these problems. When it comes to quizzes, okay, quiz, I don't remember. You might need your packet for the quiz too. But for exams, whatever CPI numbers you need for the exam, it will be given to you in the exam. Alyssa, can you always set these problems up like this? Yes. Anytime you are doing a comparison over time dealing with money using CPI, this setup will work. And that's why I like it, because I'm a creature of habit. Yes. And once you know what you're doing, it just makes it a whole lot easier. Yep. All right, so that's section 6, which took a little longer than I expected, but you know what? We're living the dream. So let's go to section 7, working with percents. We are going to do percent problems, and we're going to do them 2 ways. We're going to do them with proportions, and we're going to do them with equations. We're going to do 2 examples of each. I don't care which way you do it after this, but I would like you to try it with us, proportions and equations. Try it both ways and then make a decision. I am a big fan of proportions because proportional reasoning just makes sense in my head. I don't know why. I can't explain it. It's just the way it works. So when we talk about proportions, there's 2 ways that we're going to think about this. One of them is percent over 100 is over of. And right there is where people go, what? Well, some problems they talk about is and of, like 30% of 80 is 24. There's an is and of in that statement. Another way to think about this, same concept, percent over 100 is part to whole. So if you watch the ratio videos from like section 2, you talked about part to whole ratios, right? So there it is. So either one of these thought processes will work for proportions. When we're talking about equations, the key that you have to remember is that is means equals, of means to multiply, or I sometimes use a dot, and the last one, the percent, you have to change it to a decimal. And this right there is why I don't like the equations as much. When you're dealing with proportions, you don't have to change anything. You shove it in the proportion, you solve it, and there's your answer. When you deal with equations, you have to make sure you're properly changing between decimals and percents. It's very, very crucial. We don't play with percents, we play with decimals or fractions. That's why it works over here, because when we plug that percent over 100, we just created a fraction, and we can play with fractions. So, all right, let's do some problems. Erase all drawings. Next page. So we're going to start with proportions. We're going to do 2 problems with proportions. Work with me here. Now, I always start with the percent when I'm talking about proportions, because recall, percent over 100 is over of. So 16%, well, that means I'm going to take 16 and put it over 100. Because the percent always goes over 100. I like that. I have half of my proportion written before I've even done any thinking, right? And then I look, analyze, of what number is 40. So is goes on top. Well, is 40. So 40 goes on top of what number? I don't know. And there's my equation, or my what is this called? A proportion. So I cross multiply. And just to refresh, that gives me 16x equals 4,000. I want x by itself, so I'm going to divide both sides by 16. And this comes out pretty nicely, 250. So there is the proportional way of doing this problem. Look how many of you had 250 before I even got there. Okay, so that's the key. Percent over 100 is over of. All right, you do one. Using a proportion. And you guys are good. What percent gives you x over 100? I don't want to go too fast, but I don't want to go too slow either. Is goes on the top, right? Is represents the part, of represents the whole. So part over whole. Then we cross multiply, and it does come out nicely. Do you need the percent sign at the end of this number? Yes is the correct answer. Good job, Alyssa. Way to be quick on that. Yes, the question said what percent, and therefore your answer needs to be given as a percent. So you end up, you cross multiply, you divide, you end up with x equals 40, but go back and look at the question. It said what percent, so you shove a percent sign at the end of that. Okay? All right, so that's, and don't worry, we're going to do a few more of these when we get to story problems, but I now want to switch gears to equations. And sometimes I think equations are easier with these straight up problems like this, but when we get into story problems that have like more words, sometimes the proportions are a little bit easier. So let me just go through an easy problem with you, because this is, I set this one up on purpose. When you're going to do equations, you need to change this. It has words in it. We need to change this word equation to a numerical equation. So first thing we start with is 30%. But as I mentioned earlier, you can't play with percents. So what is 30% as a decimal? 0.3. Thank you. So I have 0.3. What does of stand for? times. Excellent. I'm going to use parentheses to show my multiplication just because, I mean, you can use the x if you want, but I hate it because x is an unknown value. You can use multiplication dot. You can use parentheses. Any of those will work when talking about multiplication. So we're multiplying by 80, so I'm going to go ahead and just chuck 80 in there. What does is stand for? Equals. You're ready for that one. And then we have the what number. So I have x. So the reason I say this is an easy one is because once you have it written, right, that's the hard part. Once you have it written, all you're doing is multiplying 0.3 times 80. Well, what's 0.3 times 80? 24. So that one was pretty good once we got it written. Okay, sometimes there's going to be an extra step, and that's the next one you're going to do on your own. You're welcome. All right, I want you guys to try 7 on your own. Where's my button? Write an equation, please. So this one starts with what percent? All right, so we have our x value. As before, of means multiply, so I'm going to go ahead and multiply by 300. Is gives us our equal sign, and we have 125. All right, so then change color for fun effects. Right, the equal sign breaks it into 2 equal halves, so we're going to divide both sides by 300 to get x by itself. Now when you do that, your calculator will spit at you 0.41666666666. We're going to go ahead and round. But remember, the question said what percent? So we have to change, don't get lazy, this is a decimal. We've got to change it to a percent. And if you check out the chat box, multiplying by 100 turns 0.4167 into 41.67%. Yep. Okay, so there we have done a basic showing of proportions and equations, and now you can use whatever you want. I don't care. Different people's brains like different things. I want you to use what works for you. If you email me about any of these questions, I simply ask that you specify what you prefer. Because if you ask me about one of these and I answer back in terms of a proportion and you want to use an equation, then we're speaking 2 different languages. So just make sure that I know what language you're speaking so I can accurately help you. Okay? All right, I want you guys to try this one. Sarah's paycheck was $1,750 and she pays $800 in rent. What percent of her paycheck goes to rent? I don't care how you set it up, how you figure it out. If you send a carrier pigeon and somebody replies back, go for it. Figure out what percent of her paycheck goes to rent. Thank you. Okay. I'm going to go ahead and set this up both ways just so that you can see it. When you see what percent, well, that tells me x over 100. What percent? Now, in this case, we don't necessarily have an is or an of, but we have a part to the whole, right? Her whole paycheck is $1,750. The part of her paycheck is $800. So that's the proportional method. If you wanted to use an equation, well, what percent, I don't know, of her paycheck, so we're multiplying by her paycheck, is rent. Right? That's kind of what we're dealing with. Either way, if you check out the chat box, you do end up with 45.71%. Does anybody have any questions on that? And again, I don't care which way you do it. I just want to make sure you're doing it mathematically correctly. So either one of those is sufficient. You also kind of could have just considered 800 divided by 1750 and changed that to a percent. Mathematically, it's equivalent. No questions? Everybody's okay? Everybody understands? I don't see any hands up. Nothing in the chat box. All right, let's try one more of those. In number 9, of course, this is made up because I'm sure that number is higher. 36% of students think math is the best subject. If 48 students think math is the best, how many total students are there? And now when you're rounding, make sure you're paying attention. You're talking about students. You cannot have 0.3, 0.7 of a student. I mean, as an instructor, I think some of you give that kind of effort. But we're talking about people here, so we should have a whole number. Okay, answers are trickling in, so I'm going to go ahead and kind of set this up. Again, I'm going to do both ways. So 36% as a proportion, we know that the percent always goes over 100. Now on this side, we're talking part to whole. 48 students think math is the best. Well, that's not all students. It should be, but it's not. And how many total students are there? So we're looking for X. And in terms of an equation, let me change colors because that's half my excitement. 36% as a decimal is 0.36 of students. I don't know how many total students there are, but I know the good ones like math. Either way you look at it, when you check the chat box, the answer is correct. This rounds to 133 students total that we are dealing with. Okay. Questions, comments, concerns, suggestions, cuss words, dealing with section 7, playing with percents. All right, so we are halfway through today's lesson and we're actually doing pretty decent on time. I'm kind of impressed with myself right now. So we're going to move on to section 8, which is descriptive statistics. Now, most of this you have probably seen at some point in your life. It might have been a while since you've seen it. So we're going to talk about the mean, median, mode, range, and percentiles. One thing that I do want to mention is that Excel will be your friend. It is important that you can do some of this by hand, but it's also important that you recognize Excel can be used for this. If you have no idea how to do any of these things or some of these things in Excel, do not worry. Remember, as I mentioned before at the beginning of class, I posted videos under the announcement tab. One of them is descriptive statistics in Excel, and it will talk about all 5 of these things. Actually, I think more than these 5. There's also min, max, everything else. That how to do that in Excel, where to find the formulas, how to type in the numbers. It's not bad once you learn how to do it. So if you don't know how to do this in Excel, I'm not going to talk about it today right now. You need to watch that video. It's like 9 minutes long. It'll walk you through how to do it, and then you'll be good to go. You will be asked to use Excel for some of your homework problems. You will be asked for some of them to be done by hand. So make sure you're paying attention to the directions in the problem. All right, let's talk about just real quick, what do these mean? What is the mean? The average. Good. So that is one way to think about it. And when you go into Excel, the formula for this actually is average. Yeah. So going more specific, we are going to take the sum of all the numbers. Sum means to add them all up. And we are going to divide by the total, right? How many numbers are there? Total number. Okay. So that's the mean. Add and divide. The median. What's the median? The middle. And more specific, your numbers need to be in order least to greatest. So your first step is always to make sure that your numbers are in order least to greatest before you find the middle number. If you don't, you're definitely just not going to be correct. All right, now let's go to the mode. Most common, right? Because you've got the O, mode, most. What about the range? Nobody's got the range? Largest minus the smallest. Excellent. I'm going to use smaller words because those are long. But the max minus the min. Yeah, if you take the biggest number and you subtract the smallest number, you now have the range. All right, the last one, talking about percentiles. So percentiles, hopefully, when you think percent, you think of 100, right? So percentile basically means we're going to break them up into well, if you had 100 numbers, let me think about this. If we had 100 numbers set up, the 10th number would be the 10th percentile. The 30th number would be the 30th percentile. We are never going to deal with a number set of 100. So percentiles by hand are very, very difficult. Percentiles in Excel, rock my socks, because you type in a couple numbers and Excel punches out a number and boom, you're golden. We will do the 25th, 50th, and 75th percentiles by hand today because those are a little bit easier to deal with. Okay, but percentiles do deal with 100 just like the percents that you would think. Okay, let's do some math. All right, so we have a number set here. We're going to find the mean, median, mode, range, 25th and 75th percentile. You're welcome. I put them in order least to greatest for you. Now, one thing that I do want to point out is that this number 10 over here is the problem number. It is not part of the problem. Okay, so that number does not belong as part of this problem. That could cause you issue. All right, so I want you to do A through D. Okay, find the mean, median, mode, and range. We're going to do the percentiles together. So I'm going to give you a minute to do the first four. All right, so we've got some numbers typing in. Mean 23.43, mode 32, median 24. Is there a range 20? Those match my numbers. If any of those don't make sense, you're not sure where they came from, make sure you holler. Okay, so we're going to build on that. The median is 24. That is the perfectest, straightest line I've ever drawn in my whole life freehand. Let's have a party. Okay, so the median cuts this directly in half. Now, if we go back to our concept of if we had 100 numbers, right? So think about all of this being, 100 numbers. If we're halfway between that, what percentile is halfway between 0 and 100? These are the percentiles we're dealing with. 50, right? So these blues are the percentiles. Okay. So the median is also known as the 50th percentile because it's halfway between the smallest and biggest numbers. Okay, now think about this. If you're going from 0 to 50, what is halfway between 0 and 50? 25. So thinking of the concept, if I now just focus on the front half of my numbers, which is 0 to 50, if I take that halfway point, I have the 25th percentile. And the middle point, or the halfway point, is the median. So the median of my front half is my 25th percentile. Now you'll see that 24, I call these things trees. If 24 is a tree and we slice it in half, that tree is dead. And if you kill a tree, you can't use it again. So 24 is dead. So I only have these 3 trees to play with, and that makes 16 my 25th percentile. Stop me if I'm not making sense. When I look at my top half, if I go from 50 all the way to 100, right, what's halfway between 50 and 100? 75. Again, 24 is dead, so I don't use it. So 32 is my 75th percentile. One thing I kind of want to show you, it's not what I wanted to use. Orange will work. After I've drawn my vertical lines, notice how I have one number in front of the first vertical line. I have one number between the second and the third, one number between the second and the third, first and second, third, whatever. I've got one number between each vertical line, right? That's how it should work when you're breaking this up into 25th, 50th, and 75th percentiles. So the 25th is 16, the 75th is 32. Okay. We're going to do another one of these, mainly for the percentiles. I feel like A through D is kind of like riding a bike. Once you get it because you've done it before. But the percentiles, not all of us have done those by hand. So, all right, let's do another one of those. This one just has 6 numbers. Again, go ahead and do A through D, and then we'll kind of talk through E and F together. You can try E and F on your own, but this one is a little bit different. Okay. I like how different people have different answers for, missing different pieces. I like that. Okay, so we have a part A, 55.67. That is correct. When you add these 6 numbers together, you should get 334. There are 6 numbers, so you divide by 6 to get that 55.67. We'll come back to the median in just a minute. The mode is 60 because it's there twice, and the range, 63 minus 43, gives you a 20. Yes. All right. So now, if you go to the median, you'll notice that there is no exact number in the middle. So I cut between 2 trees, right? The median is exactly in the middle. Well, exactly in the middle falls between 58 and 60. So between 58 and 60 is 59, right? If you need to, you can add those together. and divide by 2, right? Take the average of those two numbers and you get 59 for the median. Now, when you go then to think about your percentiles, so I did not cut down a tree with my median. I cut between trees. So when I go to find my 25th percent, I'm using all three of these numbers. Well, if I'm using all three of those numbers, I'm going to hack down. My 25th percentile is 50. Similarly, when I go to find the 75th percentile, I'm using all three of these numbers because I did not chop in 60. And therefore, 60 is my 75th percentile. The same kind of thing that I did earlier. If you look between the vertical lines, one number before the first one number between the first and second, one number between the second and third, one number after the third. So you should have the same number of numbers in between each vertical line. All right, and the more you do those, the easier they get. Okay, so that's that. If you don't know how to do it in Excel, watch the Excel video. It will help you. All right. Okay. Enough of that. Moving on. Symmetrical versus skewness. I'm going to spend 30 seconds talking about this. Basically, if you have symmetry, that's the same left and right. If you cut down the middle, darn it, still not very good with these pens. If you cut down the middle, you have the same on the right and the left. In this case, the mean equals the median, and the mode for that matter, but we don't get too much into that. Okay, when you talk about skewed right, when we're talking about being skewed right, that means your tail is to the right. So the tail goes to the right, it's skewed right. When you are skewed right, the mean is greater than the median. And I remember this by which way is the tail going? Tail's going to the right, it's pointing to the right. So the mean, always have the mean first. Mean is greater than the median when your tail goes to the right. So this might be representative of the ages of people at an amusement park. You're going to have way more young people than old people at an amusement park. Okay. Then skewed left goes opposite, where you have big on the side and your tail goes to the left. So thinking through that, if your tail's pointing to the left, that means your mean is less than the median. This might be representative of age of people who do the New York Times crossword puzzle. Right? I don't know anybody under the age of 35 that does the New York Times crossword puzzle. Let's go. I don't know anybody who does the New York Times crossword puzzle. But there you go. Okay? So just kind of keep those pictures in mind, what they mean. There's a whole video and page on that in your packet. Recommend, if this doesn't make sense to you, watch that. You'll get a little bit more. But just know that it's, you need to at least have an idea of what's going on there. All right, the last section of the day is weighted averages. We're going to do weighted averages in two different ways. One of them is course grade, right? Anything with percentages. So your grade in this class is weighted with percents. And then we're going to do counts. An example of that would be a GPA or anything with numbers. So we're going to do a couple examples of these, and then we'll go over the project, exam 1, and we'll call it a day. We should finish up by 10 after at the latest, so not too bad. All right. So we're first going to start with a percent. And I know that this is a percent problem because, all of these things have percents, right? They're weights with percents. So when we do this, I need a pen. You kind of got to think about, I like to create tables because I'm an organized person and that just makes me feel better. So when I'm thinking about, I have homework, quizzes, projects, and exams, and these are the weights. Right? Then you've got to kind of think about points. How many points did you earn in each of these sections? Well, when you look over to the right, you have 4 grades for the homework. I can't give you 4 different spots here. We need to find the category average. Okay, so the points are found by taking the category average. And we know how to find average. We just did that. So for homework, you have 4 grades, 100, 90, 95, and 97. What is my category average for homework? if there's 4 scores, there you go, 95.5. We're going to add all 4 of those together, 100 plus 90 plus 95 plus 97, and then divide by 4. So as Samantha said, we have a category average of 95.5. Okay, so that's homework. Then we go to quizzes. I believe I have 3 homework quizzes, 3 quiz grades, 80, 70, 85. What is my average quiz grade? $78.3, good. We have 2 projects at 90 to 98. Average of my projects. If anybody is unsure where we're getting these numbers, all you got to do is shoot something in the chat box. Okay. And then exams, 100 plus 80 divided by 2 gives us 90. Okay. So once you have the category average, or the points as I call it, then we need to figure out I call them quality points. I don't know why, it's kind of just what I do. Your quality points, and I use that term for both percents and counts. Quality points tell us, okay, if you had a 95.5 total points in homework, but that was only 10% of your grade, how many quality points of that goes towards your grade? So we're going to multiply. So I'm going to take my 10%, which is 0.1, and I'm going to multiply that by 95.5. So 0.1 times 95.5 gives us 9.55. Good. So your part of your grade, 9.55 points come from homework. Then I'm going to take 20% for my quizzes, right? 0.2, and multiply that by 78.3 to give it my quality points for quizzes. 15.66. Then I'm going to go to projects, 25%, so 0.25 times 94. 23.5. And last but not least, exams, 45% is 0.45, and I'm going to multiply that by 90. 40.5. So you can see the higher a category is weighted, in this case the exams are 45%, you're going to get more points, which should make sense logically. All right, so now that I have my quality points, if I total up this column, so if I add up 9.55, 15.66, 23.5, 40.5, how many total quality points does this person earn? 89.21. And if you think about this, we would divide by the total weight, but the total weight is 100%. That's just 1. If you divide that by 1, you simply get 89.21. So your grade in this class is an 89.21. Well, that's a B. So sorry about your luck. All right, look at what not doing so well on quizzes can do for you. Okay, so that's an example of what the percent weighted average looks like. Okay, most people don't have too many problems with those because they all kind of look the same. So let's now go to accounts. So the first one we're going to do is not a GPA problem. We're going to talk about Sarah. She's selling 8 watches for $45 each, 12 necklaces for $60, and 35 clocks for $92. What is the average cost of an item? If you are a visual person, I highly recommend you make a table, right? She's got watches, she's got necklaces, and she's got clocks. She's got 8 watches, she has 12 necklaces, and she has 35 clocks. Whoa, that got a little bit big. So this is the number of items and the price of an item. So we're talking 45, we're talking 60 for the necklaces, and 92 for the clocks. I simply took the information from the sentences and I put it into a nice organized table. Anybody have any idea how we're going to work next in this problem, what we should do next? Nobody? All right, we're going to kind of keep the same concept from the last one. Remember in the last problem we did total quality points divided by the weights, right? The total weight. So because we don't have weights in this one, we want to know the average cost. So we're looking at total cost over the total number of items. So thinking about if I have 8 watches and they're $45 each, well, how much total is that for watches? Right? Well, if I multiply 8 times 45, that'll tell me how much my watches are worth. Right? So 8 times 45 tells me my total cost, right? That's what I'm trying to find here in this third column. My total cost is $360 for watches. Then for necklaces, I take 12 times 60, and my total cost for necklaces is $720. My total cost for clocks is $32.20. Do people buy that many clocks? I don't know. I made up the problem. And then we add, because right, the numerator that I want is total cost. Well, if I add all of these up, thanks Scott, I get $4,300. But that's not my average cost. That's the total cost of all my items. I have to divide that by how many items do I have. So if I go over to my total items here, how many total items do I have? I've got more than 3 items. I have 3 categories of items, watches, necklaces, and clocks, but I have 8 watches and 12 necklaces and 35 clocks. So the total is 55. There we go. So to find my average cost, I will take the 4,300, divide by the 55 items, and that gives me a cost of $78.18. And that should make sense. The lowest priced item was 45. The largest priced item was 92. So your average item cost should be somewhere between those two, right? Somewhere between those two. All right, I want to do a GPA problem, and then I'm done with math. So when you do the GPA problems, they're going to tell you that an A is 4 point, a B is 3, a C is 2, a D is 1, and an F gets you nothing, which makes sense because you failed, right? So they're going to give you that information. I just assume people know that if they're in college, but I know that not everybody does. So they give you the grades as letters. You need to assign the point values for those. So as I just wrote up here in green, every C gets you 2 points per credit hour. An A gives you 4, a B a 3, D is 1, and B is a 3. Now, what I just mentioned is that these points are per credit hour. Per credit hour. Which means if you got a C in a 3 credit hour class, you don't only get 2 points. You get how many? If you get 2 points per credit hour and it's 3 credit hours, how many total points do you get for biology? 6. Very good. Because we're going to take points per credit hour. So then for math, you got an A, which is 4 points. Multiply it by 3 credits. So how many points did you earn? 12. Testing your multiplication skills here, right? English, you got a B, so we're talking 3 times 3, which is 9. You slept through history, so you got a D, that gives you 4 points. And then sociology, was okay, so you got 9 points. So that now gives us our total points. So thinking through this, our total points, what are we going to divide by to find our GPA? Total points divided by, anybody have any idea? Total credits. It's not just the number of classes, it's the number of credit hours. Exactly. So for this particular problem, you did earn 40 total points. Congratulations. But how many credit hours did you take? So 3, 6, 9, 12, 16. So we'll take 40 divided by 16. You have a GPA of 2.5. right? You've got to make sure you're dividing by credit hours because it wouldn't make sense. I mean, if you took 18 credit hours and earned 18 points and somebody else took, 3 credit hour or 10 credit hours and earned 30 points, whatever, right? So you've got to make sure you're dividing, otherwise it just doesn't make any damn sense. So you want to divide by your credit hours. Total points divided by the credit hours gives you your GPA. And again, the points are from 0 to 4. So your final GPA answer should be somewhere between 0 and 4. If you got all A's, you have a 4. If you got all F's, you have a 0. If you have a mixture in there, you're going to have somewhere between a 0 and a 4. Okay? All right, that is the last last thing I have there. Okay, so a few things that I just want to bring up to you. First off is Project 1. So Project 1 is found in Module 4. It looks like this. I just want to spend 30 seconds and remind you that you have to create an Excel spreadsheet. These are the pieces that have to be in it. I use this exact document to grade. Okay? Then you're going to do a typed reflection paper. Yes, in a Word document. And you want to fit these pieces, right? All of these, son of a biscuit, why do I keep doing that? You want these pieces. I am going to be looking, this is my rubric for grading your projects. Okay? Down here just kind of helps you figure out whether or not you're doing this correctly. This right here, use the following parameters in your Excel spreadsheet. This is what you're going to use for your project. These pieces right here. They're different from past semesters, so don't be cheating and using somebody's from last semester because that comes up every time and it's bad. New stuff every semester. There you go. If you have no idea how to do this Excel spreadsheet, that's where I posted a video. It's about 3 minutes long, and it will walk you through kind of how to get started with your Excel document for this project. I don't remember what the due date is off the top of my head. It's in the calendar. So if you go to your calendar in IB Learn and look for Project 1, that is an absolute due date. There is no extension. That's the due date. You lose 20% for every day it's late after that due date. So you want to probably get started on this, sometime in the near future and get going with that. Scott, this class is 3 credits and 4 contacts, which means it is a 3 credit hour class. You're welcome. Okay, the second thing is your exam. We have officially, right, we're done, I use that term loosely, with Unit 1. That's through Section 9. That means your next big thing is your Exam 1. Exam 1 is due no later than the 24th, which is 10 days from today. You are going to need to make an appointment to take your exam. So if you go to Ivy Learn and you click on the help document or help button at the bottom, at the very top you see Ivy Learn Student Resource Center. If you click on that, you then see Testing Center. I guess you open in a new tab. Look at these tabs I have open. If you scroll down, it says Schedule Now. If you click on that, you can then go through the steps to schedule your math exams. You have 90 minutes to take Exam 1, 90 minutes for Exam 2, and 120 minutes. That's 2 hours for Exam 3. We'll talk more about Exams 2 and 3 as we get closer to them. But you're going to want to plan ahead. When are you taking your exam next week? If you want to take it on Friday, then schedule it now for Friday at whatever time you want to take it and get it on your calendar. If you want to take it next Friday at 2 o'clock and you try to schedule it next Friday at 1 and they won't let you, don't come crying to me because you can't get in and you need an extension. The answer to that is no. No extensions will be granted on Exam 1. The due date is the 24th at noon, and you need to have it done on the 24th at noon. If you don't, it's a 0. No ifs, ands, or buts. That's how it is. So plan ahead and do not come crying to me when you need help because I will not give it. Okay? So make sure you get that scheduled now. Get it taken care of. If you need help scheduling or if you have questions, let me know now so we can get that taken before next week. Okay, I'm not very lenient when people wait to the last minute and then have issues. It's not my emergency. So take care of it now so you don't have issues later. Okay, that is the end of my rant. That is the end of my class. I'm officially done. It's 2:09. I said I'd be done by 2:10. That's pretty good. If you have any questions about homework or anything else, I will take those at this time. If you have no questions, exit out, have a great day, and keep working hard, or start working hard if you haven't started that yet. Thanks. Bye, everybody.
Becky, I got a couple questions on,
Jessica?
yes.
Okay.
I'm sorry, I was a little slow on section 7, and for some reason I'm going back through what I've written down, and it still looks confusing to me, and I don't know why, but
Are you talking
maybe
about
you can
a problem that
shed the
we
light.
did, problem that we did in this class?
Yes, yes, what we just talked about.
Which
In section 7, working with percentages.
Which one is causing you issues?
That last one, number 8.
This one?
Even though you went through and you explained it to us on how to set it up,
Mhm.
I am still looking at it dumbfounded, trying
Okay.
to figure it out.
So I would recommend, if you're okay with me recommending things,
Yes.
if you can solve a proportion, I would absolutely recommend doing all of these with proportions. They're just easier because you can
Okay.
set them all up the same way. And so when you're looking at this problem and you read it, I always locate my percent first because I know that half of my proportion has to be dealing with the percent. So when I read this problem and I see what percent, well, the what tells me I have the unknown value, right? So
Right.
the percent is always over 100. So I know I don't know the percent. There we go. Okay, so I have half of my proportion set up. Didn't even have to think yet, which is the good. Now, you know that the other part has to be numbers. So the question now becomes what numbers go where? It's always going to be the case that you're going to put part over whole. Okay, so when you think about these other numbers that you have, you've got her paycheck was $1,750 and she's paying $800 in rent. Okay, well, which one of those is part and which one is whole in terms of the money that she's got?
Well, 1750 would be the part, and then the whole is 800. Or sorry, I'm sorry. See there, I just screwed up. 1750 is the whole, and she pays 800 in rent.
There you go. So if you're talking about, okay, her whole check is $1,750. The part that she's dishing out is 800. So if you can think of, and sometimes it helps to talk through it, right? Because I didn't say anything. You said it out loud and then said, oh, nope, that's backwards. So sometimes it does help just to hear it. So feel free to talk to yourself. You can't talk to yourself during the exam, but, I mean, your kids might be crazy, but hey, go with it, right? I think you're crazy. So,
no, I think that's my issue too, because if I just sit there and read and if I don't talk out loud, then I'm just like, what?
Oh, yeah.
What is going on here? I'm a little confused.
I talk to myself all the time. So it's
You're not the only one.
Yeah, it's a good thing. It's a good thing. So, yeah, so does that kind of help thinking through it that way?
Yes, that does help a little bit. It's just, like I said before, those word problems is there. If math is already difficult enough for me as is, but when you throw a word problem at me, I have a very hard time deciphering it out and getting it set up to solve.
Have you watched any of the videos or worked through anything for Section 7 yet?
No, I have not.
Okay. There's
not yet.
There are quite a few pages in Section 7 that some of them are, a little bit easier, meaning they're more like these problems that are very straightforward. But there are quite a few of the story problems. And I would really recommend, because the more you do, you're going to kind of start to almost see a pattern of what you're looking for. Even though they're all different and they have different concepts and different topics and different numbers, you're going to start to kind of pick up a pattern of what goes where and how they're worded, of where the part and the whole fit. Just because, people have patterns to language, right? When we start talking about language. So when after you get, maybe 5 or 6 under your belt, you're going to start to see that pattern come through in the math. And that will make setting them up easier. So I would recommend, I don't know if you normally watch all the videos or if you only watch some. I would watch.
No. And go back and I watch your videos for the packet quite a bit.
Yeah. So I would watch every video from section 7 in the packet for sure, because they,
Okay.
and you might even want to try, I don't know how people are working through, but sometimes it might help before you even turn the video on, try to do the page, right? Do it, see what it looks like, and then watch the video to see where you're at. And then if you get one wrong, you can see why it's wrong. And then if you still don't understand, then you can kind of reach out and we can talk about it later.
Okay.
But I think the more you do, the easier they will get. That's
right.
Generally how it is. And, you know, having an hour and 10 minutes to do 4 sections, we don't have time to do, you know, 20 examples. Where if you were in this class face-to-face, section 7, we would do like 20 examples in class. So it's just a completely different, you know, format of class of how much time we have for things.
Okay, right, which is totally understandable. But I just, before I hopped off here, I wanted to make sure, like, just that, like I said, word problems
Yeah.
are difficult for me to comprehend at times. So.
And, you know, as you're working through over the next few days, if you need more discussion through it and you want to, you know, if we need to throw up another, you know, optional session a different day and time, you know, just let me know, just like we did this week. We can make that work. Okay.
Okay.
So.
All right, Becky. Yeah, thank you very much. Yeah, I'll definitely, you'll probably be hearing back from me.
No problem. No problem.
Okay, well, take care. Have a good day.
You too. Thanks. Bye.
Thanks.